Okay, question 34, on the same diagram, sketch the graphs of y equals ln x and y equals 11 minus 2x. Deduce the number of roots then. Okay, now let's just do this. We need to know, right? We need to sort of have a good idea of what ln x is. We need to remember this for the exam. It's quite important that you understand what they look like. Okay, same with e to the x as well. Now ln x, basically, it goes like that, yeah? So it doesn't take any negative values. If you put ln like minus something, it comes out as error, right? And it will not be 0 as well. If you put ln 0, it comes out as math error. It doesn't exist. So it's kind of, this is like acts as an asymptote. It never quite gets there. And then it sort of starts to, as x increases, y then starts to get bigger. Okay, so it kind of goes like that, and it crosses here at 1, right? That's important, because if you put in ln 1, okay, you get out 0. So in the exam, if you can't remember, just put in some important values. You might think, okay, what happens when x is 0? Well, you get math error, because it doesn't exist. Okay, it never quite gets to 0, it goes to infinity. If you put 1 in, it comes out as 0. Okay, and then just try for other values. If you put 10 in, okay, you can see it's 2.3. Okay, you put 100 in, 4.6. It doesn't rise quickly. You can see how I've done it quite flat there, right? But it does rise as you go on with the x values. Okay, you can see it rises really slowly. Okay, but it does rise and it will go to infinity. So that's ln x. Now this one then, y equals 11 minus 2x. Now you've got to remember the idea from GCSE that you learned, y equals mx plus c. Okay, if you remember y equals mx plus c, the m bit, the number in front of the x, tells you the gradient. So the gradient in this case is minus 2. And the c bit, right, tells you the y-intercept. So maybe you would want to rewrite this particular line here so it's in a sort of order. So this would be written as minus 2x plus 11, right? If we write it the other way around, you can do that, right? And it might make it easier to see, because the number in front of the x is the gradient. This is where, this 11 here is where it cuts the y-axis. So we need to have it cutting the y-axis here. Okay, at 11. Okay, that's where it is. This is a straight line, by the way, right? Because there's no squares, cubes, or anything. It is a straight line, right? So that's why I've come to this idea here. They're always straight lines. The gradient's minus 2. So what that means is, for every one you go across, right, you go down 2. Okay, now I know my scale isn't brilliant here, okay, it doesn't matter. But for every one you go across, so we go across 1 there, you're going down 2. So we end up like that, right? Go across 1, you end up going down 2. Okay, it's a negative gradient. So you've got then your straight line like that. It doesn't matter, it's just a sketch at the end of the day, just to show the idea that you've got the idea that it cuts the y-axis there at 11, right? So I put 11 there, and then this negative gradient. Okay. The other way you could draw this is just pick some points out. You know, you could set x to equal 0, y would be 11. You could set x to equal 1, y would be 9. You know, and you could get a few points so you know where to draw it. Okay. So then it says deduce the number of roots for this equation here. Now, basically what they've done is, right, is they've tried to solve them simultaneously. Okay. So if we solve them simultaneously, we're interested in if they intersect. So when they intersect, the y's are the same. So you'd basically be putting ln x, you put the y's equal, wouldn't you? Okay, to solve them simultaneously. And if you do that, then you get everything over the other side, and you get this, don't you? And you get exactly what they've got here. So when it says deduce the number of roots of the equation, in other words, what it's saying is, right, number of roots of the equation here, how many x values give you this answer? How many x values will give you this answer to be 0? Okay, and you've got to appreciate then this is associated with this here in terms of the fact that we're solving simultaneously. Okay, so we're looking at how many x values here where these are equal. Well, how many times do they intersect? They only intersect once, don't they? Okay. So that means there's only be one x value where this is true, right? This simultaneously works. There's only one x value. There's only one x value here, so we've only got one root here. Okay, that's our answer.